Evening, everyone. It's Monday. It certainly does feel like a Monday for me, at least. Um, let's go look at our syllabus, where we're going to stand today. Syllabus. It's October 5th, so keep eyes on the goal. Today we'll go over practice programs, writing functions with our seeds program. We'll also review Chapter 6. Then come on Wednesday, we will just have Chapter 6. The only thing that we will do in class is go over Lab 4. So you understand what's expected of you into Lab 4. Other than that, on Wednesday, there's no lecture, there's just questions, because come on Monday, there is your midterm. And on midterm, you have, when I set it up, I think you might have all the way to, let's say, I would say 10 o'clock to take your midterm.
Excuse me, sir.
Uh-huh.
May I ask questions about the lab that's due this Wednesday? I think may I ask them or not?
You can ask. Go ahead.
All right, because it was about I was gonna share my screen and show what I have right now, and then I was gonna ask about specific methods if we're able to use them or not.
Well, let's first of all do this Lab 6 and review, and then we'll take that after the lecture. Is that okay? Then I can get with you, and you can share me your screen and describe what you're doing.
All right, sure.
And who was this? I remember.
Justin, that's who
Justin.
I'm talking.
Okay. It's hard to hear when I don't see it, just the voice. All right. Justin, get with me after class, and we'll get together, and you can share your screen, and then you can describe the questions you have.
All
All
right.
right. We're going to do review of Chapter 6 today, and go over in labs regarding general functions. Other than that, let's get started. Just remember, a week from today, you have your midterm. Wednesday, we'll go have quiz. We'll go over what's Lab 4 is all about, and if you have any questions before Monday. So let's go ahead. Can everyone see Visual Studio from my screen?
I can.
Okay, thank you. Even though we talked about that you may or may not need to write prototypes for this lab, I will write prototypes just to give practice with them. As you can see with our flow, we do this values repeated check, while this get tickets A, tickets B, and so forth. So let's come up with a method. When I say method, it's Java talk. Methods and functions. They're called functions in C and C++, but in Java they're called methods. So if you hear me use the term interchangeably, because most of the time I'm in Java, so we use methods. So let's create a function that takes in an argument and then returns something back that we can use. So in other words, let's create a prototype that I'm going to put after the preprocessor directives and after using namespace before main that returns an int ticket sold. And we'll call it ticket sold. And I'm going to pass it in a char, which means I'm going to write a function that returns an int that does prompt, and then returns a char takes in a char so I can display that character, that seat type, and then return that seat, how many tickets were sold. Does that make sense? And then we're going to also demonstrate how another function can call a function. So for right now, since I define this function, I need to define what it does after main. So I'm going to copy this. I mean, it's easy to copy. It'll be after main. What do we call this right here? This is also part of review. What do we call this?
What do we call which part?
That seed type that I just highlighted.
Oh,
Is it the argument?
No, it's not the argument. Remember, argument is something that you actually pass, A for actual. Am I passing that seed type?
no, you're not passing the data type, no.
So this is what we call a parameter. It's a placeholder.
Right.
Right now, I'm just taking this method call that we all wrote before. Please enter the amount of seed for type A. But I don't have this type, and that's what I'm going to pass in. So I am going to use the same method that we did, and I'm just going to seed type. Seed type. Please enter seed type right here. There it goes. I'm not going to read it in here, but I'm going to have a temporary variable right here. Well, we can read in num sold. I'm on the Mac and on the Windows emulation, so I use num sold. Num sold. Okay. All I did was take that block that we have in the code, and now I made a function, something reusable out of it. So I'm passing in the seed type. This is a parameter right here. And I'm using a temporary holding thing because tickets A did not make sense. So right now, it's going to read in this value, and when it's done, I want to return num sold. Does that make sense to everyone what we're doing right now? So I have this variable that's local. The scope of it is within this function and nothing else. So I'm going to pass in, please enter amount seed types. This seed type is a placeholder because I'm going to pass it in later A, B, and C. Same logic that we had before over and over again, but I'm not using it. It's not going to be, how can I say it? Copied and paste throughout the code. It's in one spot only. And then once all the information is good, I return that num seats sold. Does everyone understand right now? This function.
Yeah, I do.
This function right now is not being called. I just created it. So inside here, up on top right here, how do we call a function?
Wait, oh yeah, you typed the static, I believe, right?
No, how do we call this function? How do we call functions?
Oh, you type in the function name.
Right, function name. So inside right here, or I'm second, I'm gonna take the function name
But
and I'm gonna pass it in an A, right? Because I need to pass in the seat type, right? So this is gonna be seat type for A.
yeah,
But instead of reading this in, I am going to now assign the return value from it here. So I do not need this anymore. See how easy that goes?
hmm
Now, to get for B, I do the same thing again and pass it in B. So that way I don't need this. So same thing for ticket C. I don't need this. See, we just removed all the duplicate code because we created a single function to do the work for us. See how great that is? So now I have what do we call these right here? This A, B, and C.
the character.
They're characters, but they in this
Argument?
function. What?
Argument?
Argument. It's the actual value that's being passed in. Because this right here, this placeholder, C type, is going to take in A, B, and C. It's a placeholder. P for parameter, P for placeholder. That's the easy way you can remember it. So now when I run this, oh, my spacing's off, but oh well. See, we have the while loop that's catching it. So now when I enter those values, our code now is modularized. And if I have to, let's say if we get another value for, let's say we get another C types D, I don't have to copy and paste all that code. All I do is just create another one of these calls and pass that information to it. Any questions how simple it is to write a function?
I think I'm good.
From there, let's see if we can reduce this even. Let's see what else we can do. We can pull all this out and write a file, but let's see if we can do something else. Let's try doing this. Take an int boolean. What does a boolean do? What is a boolean value?
It's true or false.
False. Let's see if we can create a function that you can probably use in your layer labs and so forth. So we're going to create, where's my mouse? Copy that validator. So while num is right here, so I'm going to say while this value test and so value value is let me see if I want to do that. Value less than 0. True. Result is true. So now later on, even though this is a simple check, you can say validator less than none sold. Because now you can do conditions right here. So you're pulling your validator out to say, while it's invalid, validate it. Say, hey, while this is true, keep them here. Because now my logic is now becoming more granular and saying, all right. Because later on, what about if another program or something else, instead of validating less than 0 and so forth, what about if you say it's less than 0, then it also has to be within this other range? Well, now you're not convoluting your conditions, you're pulling them out. And so you could be able to test this method and not having to worry about everything else in this because you're modularizing your program. The smaller it gets, the better it is because these right here become testable by themselves. When you talk about testing suites and so forth in other languages, you don't have to test the entire program. You can just test certain parts of it to see if it passes or fails. As you can see, you can call functions inside an expression and so forth, and a function can call another function. Any other questions?
Ooh, a interesting thing. The validator isn't the argument for if you're checking if value is less than 0, isn't that also a Boolean?
Which one do I use less than 0?
Yeah, for the validator function.
Uh-huh.
I was gonna say either like it doesn't change. It doesn't really change like a lot of it. But would it work if you put like the only line you did in validator was return value is less than 0, and that'd be a Boolean?
We'll test it right now. Good. I mean, there's more than one ways to write things. You're saying take this, comment this out, comment this out, comment this out, and comment this out, and then this is unusable right here, like that, right?
Yeah, like that. That pretty sure that'd work.
Let's see. It might. There's more than one ways to write it. Oops, let me close this off. So, yeah, see? There's more than one ways to write things. You can later on, which you probably do in your other lab, but we don't have to do it now, but I used to do it in last classes was I would put all this, and this could be an exercise for the students to see if they can get it, to group this entire program to loop to ask the user, would you like to do this again? And prompt them either for yes or no answer. Also, make sure they validate that they can also type in capital Y, lowercase, or lowercase y, lowercase n, or capital. And also, even before we go into chapter 10, validate that it's 3, 4, or 5, or any other characters that would be invalid. So I'll leave that for you to decide how would you be able to write that to just say, well, or we can try right now. How would you be able to do that to say, run this entire program all over again if the user wanted to?
Wait,
Give them
what do you mean by like starting over the entire thing again?
not running in the program again. You don't have to start the entire program in again. The program's already running. We talk about looping, right? How can you loop this program to do it all over again? How would you do that?
Could you put it in a for loop and then you could ask it see out a statement asking if they input yes or no, and then you could break if they say yes. I mean break if
But see,
they say no.
but the thing, the for loop is usually used when you know how many times it's going to go through, right?
Wait,
That's of a for loop, is to periodically test to say, hey, I have 10 elements. I need to go through it 10 times. That's the purpose kind of like of a for loop. But we don't know how many times this is going to go. And we want to minimize the use of breaks and continues.
wouldn't wouldn't you want to separate? So take everything, take the whole program out of your initial main and create a new function, place all that within it, and then put and make initial main act like a menu in which program you're going to run.
Well, that's one way of doing it if you have a menu-driven program. But what about if we don't have a menu-driven program?
I mean, like you don't have to make it a menu, but like all your checks. I mean, your check if you want to run the program again would be within initial main, and then initial main would start off by calling onto the function that you created with all the program in it, and then after that's done, then you'd run like a ask the user, like would you like to try again, and then use all the extra functions you made, which is like the check like a value check, input validation, and then if you get like a yes answer, then you run the program again, and then else exit out.
Well, essentially, I'm saying there's multiple ways of doing it. But it's a good challenge to try to do. But if you put all this code inside a function, you're going to have to pass a lot more values back and forth. It depends on how you do it. So we can try it. My simple thing is to not get too complex is what happens if, in this case, let's see, at the very top. Let's do this. Come on, this. Tab this over. So now, what about if I do something, let's say, a do? This is just one scenario. This would be good. We'll do one scenario here, but I also want you to try to come up with your own to see how you would come up. What about if I do a do while? Let's put this stat right here. Wow. And then I'll say a character choice char again. Assign that to y. I don't care because it's going to be overridden. And while choice is equal to y or choice. Oh, it's again. Okay, it's y. I would have to prompt the user, right? So how would I prompt the user? Would you like to do it again? Again. But the trouble is, if a user types in an N, a Q, or a 1, or a 2, or a 3, how will I be able to catch that?
Would be able to catch what, like catch if what the answer was?
Right now, I'm catching the error. Right, I'm catching the character what the user entered in right here. Right?
Okay.
But then when they enter in, let's say, a 1 or a 2, well, it's not equal to this or this, right? So I don't do it again.
Mm-hmm.
When you,
Oh wait, so wait, so you're asking if they put in something that isn't a character?
but how? Well, a 1 can be a character. A dash can be a character. Anything that you have access to a keyboard, this could be a character. This could be a character.
Right.
Think about it in one set of ways that kind of says you're thinking all testing may be. Are you trying to think of a way that says I need a test for 1, 2, 3, 4, 5, and all possible combinations?
I was gonna say, I thought there is there like a I'm thinking if CN has the object has a specific property or something that checks like if it has like the length of what was inputted.
Well, it's always going to be 1 because the character is always going to be 1.
Yeah.
In this case, because remember, cin converts it all the way to the variable type. Think of it not necessarily by thinking of about a cin object or testing all possible values that it could not be. Couldn't you break it apart and say, I'm only going to allow it
Couldn't you check for the char value of y, and then say while again is equal to the char value y, or
I think you're getting on the right track there.
like y, I mean y capital, y just not capital, and then or again, and then capital N or capital, I mean, not capital.
In this case right here, I'm going to put all this in a block right here.
Or would it make more sense to make a if statement, and then else, because it wouldn't fall into any of these definitions?
But
It would
remember,
say,
if statement only executes at least once. So in this case, right here, while again is, remember what the or, if any one of these is true, it's going to be true, correct?
mm,
But I want to catch a scenario where, hey, it's not one of these.
okay, I see what you're saying.
So see out, right now it's not one of these, invalid data. Please re-enter. And cin again. So after this loop, I can make this into a function too and say, hey, again, right here, if it's not any one of these, because remember, if any one of this is true, this or loop is going to be true. The ors are going to be true. But I want to count out when it's not going to be one of them. So you can see how all these logics that we talked about, the ands, ors, nots, so forth, that can be used, because right now, if the user types in 1, I'm not testing for a 1, or I'm not testing for a multiplication sign. I'm not testing for all various types of characters. I have a small set of 4 characters that are valid. So in that case, that again must be one of these 4 options to be valid. So once it breaks out of this while loop, it's going to say, oh, okay, I'm either Y or N, and then I'm only testing it again right here. So I want you to kind of open your eyes to say, look away sometimes a different view of how to solve the problem. Don't worry about like sometimes using cin objects, but just try rationalizing what you can check for. So let's see if it works. Oh, let me close this first because it's already open. 10, 10, 10. Would you like to do it again? 6, 7, Anything else? It's not going on. But now when I say yes, it goes back and allows me to continue on. When I hit no, it exits out. Any questions about that?
I got it.
Later on, when you get more advanced and so forth, you can later on write properties files or create a function that you would use, aka a validator class, or sometimes a method like what we did right here, and say instead of passing like we did with an int, you would pass in maybe a list of potential values that you can use, and then that can run through it. Say if it contains in this list, go forth. But I just wanted to give you the notion of don't always look by the more complex way of like using a cin object or testing all possible scenarios of like numbers and characters and all those things. Sometimes look at it at a different angle to say, hey, I have only a handful of characters that could be valid, so I'm just going to look at those valid characters and I'm going to ignore the rest. So now you have written practice with functions. Do I need to always have these prototypes here? Do I need to have these?
Only if the functions that you're creating is after the initial.
After main, yes. If the functions are after main, I need to have the prototype. I need to have the blueprint of what it is. If I put all these functions above main, then I don't have to worry about it. I don't have to have these prototypes. but does this give you a good, clear, concise way of being able to handle functions? Okay. If everyone's good, let's go to the review, because I'm going to hopefully remember to save this off, because next time we're going to add more and more to it, because now we added from the beginning simple C in and C out. Then we added if condition logic to say some code needs to flow this direction, some of them need to go this way. Then we introduced looping to it, such as keeping the person there for data validation. Now we added a post check loop here that says, hey, keep on going if the user enters yes or no. So now do you see how all these are kind of, instead of doing each individual labs, how taking this single lab itself and just adding upon it, and adding upon it. Are you starting to feel comfortable now with all these chapters, with how this program is now becoming enhancing, make it more maintainable, and hopefully if it goes into production, if anything further goes on, if you have a testing suite, you can later on really enhance this program with minimal changes.
Yeah, I think I feel like with how much far we've gotten so far, like with chapters and with like experience I've had before this class, I feel like if there's ever a test where we have to write like code for like for a question, then I feel like with those two together, I could write really like manageable code in C sharp. I mean C++.
Well, even if it's C, C sharp, Java, a lot of these languages are kind of based upon the same concepts of functions, looping, these conditions. So you can take your fundamental concepts that you learned here and apply them to other languages. You just have to know the syntax of those languages. That's the whole point of this class, because now you understand the concepts. Like when I first started C and C++, and then one of my jobs, I didn't know shell scripting, but I was able to decipher some of the things like, the FI, they had it reversed. That's an if statement. So I knew how an if statement works. Say, if that part is true, it's going to do this. So taking your concepts that you hear, these principles, you can apply them to other languages. So very good. All right. And in chapter 7, we are going to enhance this even further because we don't like these hard-coded values right here. But we would, when you do arrays, we'll make this more complex by adding in parallel arrays. And that would be interesting to try to teach that remotely. It was easy to draw pictures on the board. But with that being said, let me open up another screen so we can start the review. Let me just say, I want to save this, but I just want to add another source file. And new item. Source file is fine. So remember, for the review now, you know that you don't have to have the prototype as long as you have the functions. In this seats right here, we showed you that when you create a function, you can have a return type. You have to have the return type, the name, and any parameters that you pass to it. So for a function, if it doesn't return anything, what's its return type?
Void.
Void function. And it doesn't have to take any parameters. And also, if it does take a parameter, the same parameters do not have to be, I can return a double in here. They don't have to match. So as long as you define them. So on top of that, if I take in this, is this int? Let me copy this. If I pass in a function, let's say this is function definition, integer x. If I change this function x value, function call integer y. And I call this function with a y. Well, let's make it 2 because that's what it is. And now I call this function y. And I reassign this x to a 10. Does this change y?
No, it doesn't.
Why?
Because
None.
well, you can add the at symbol before the argument when declaring your function.
But you're right. But what do we call this? You're right. It does not change it. But what do we call this passing this argument by? What do we call that? There was a specific term. Pass by.
Oh, with the at symbol, that's like
Not with the at symbol. Don't worry about that symbol. That's coming up next. But you got the concept. But without the at symbol, this variable is passed by.
oh, it's an argument.
No, this is an argument right here, but it's actually pass
Oh, parameter,
by
right?
value. By value. Remember we talked about pass by value because when you call it like here, this argument right here, this value, the actual value is copied into x. Remember that slide. When you do it like this, when you pass by value, this y value is copied into x. So any changes to this parameter right here has no effect on it.
Are you talking
However,
about value versus address?
we don't talk about it's either pass by value or reference. That was a terminology. But if, like the gentleman said, if I had an ampersand here, then the changes from right here says I am no longer copying the value, I am using the direct address of this variable. So in this case, it's going to be changed till 10. No ampersand, it's passed by value. Ampersand, it's passed by reference. Got it? This is your beacon right here. Notice in the function call, it doesn't change. I don't need to put an ampersand here. It's only in the function definition and or prototype. So pass by value, the prototype is, in this case, int function int. If we're going to use it pass by reference, the prototype would be int function integer x. I'm sorry. This. Notice the difference. These are the prototypes. Remember I said on the quizzes and exams you'll see prototypes. So this is your beacon. If you see this, whatever it is, I could be passing int x, int here, and then int reference here, and then a float here, and then maybe a float reference here. It's only in those particular spots am I concerned about that if it has the ampersand, then that placeholder in that function is what I'm concerned about. But when you call the function, you don't put the ampersand here. You just put the actual argument. This will change in chapter 9 when you talk another about pointers. But do you understand this big concept right here? This is a very important concept in this chapter.
Okay.
We talked about passing variables by value, which means it's a copy. No ampersand right here. Oh, it's a copy. So any changes to that variable right here, this y, is not seen outside. So if I have this 1,000 and change it to 10, it's still going to be 1,000. But if I put this ampersand on it, that's no longer passed by value of copy. It's passed by reference because I'm actually using the address. So that is your beacon. Any other questions and concerns while I drill you guys more to see how you understand this chapter? Because this is the last chapter of the core parts. Then the rest of the curriculum chapter, the rest of the class is easier, except for chapter 9, which talks about a little bit confusing when you talk about pointers. So let's see, just shout out the answers to these true false and see if I can catch any of you. Can everyone see these questions right here? These true false questions.
Can you zoom in a little bit?
Let me see if I can zoom in. Is that better? Let me move this over.
Yes.
Thank you. All right. Functions should be given names that reflect their purpose. True or false? Shout it out.
True.
True. Just like with variable names, you want to give them meaning, but you don't have to. Rules of the language are declared just to say they must meet certain requirements, like no reserved words. Variables with definition, they must start with an alpha or an underscore. Anything else be alphanumeric, but no special characters. This says it should be, but it doesn't say, be careful, it says have to be. Because the language does not know the purpose of the function, it just knows the syntax. Function headers are terminated with a semicolon.
False.
False. Function prototypes are terminated with a semicolon.
True.
Anyone else? And I just have the same voice.
True.
Now to repeat it. 41. Let me see if I can do this too. For those ones that do not have a mic, maybe I can do this. Send your messages out and I'll just watch it through the chat. If you do not have things up. So I can see it that way. We are number 41. If other functions are defined before main, the program will start executing at function main. If you don't have a mic, you can message it in chat too. I can see it as well. True or false?
False.
True.
True. If other functions are defined before main, the program will start executing at function main. When your program runs, remember it always looks for main and starts executing from there. You, the developer, should never call main. Nobody calls main directly. Only when the program is launching does it look for main. Do not call main itself. Even though if you have a series of functions, 100 of them in there, once the program starts, it's always going to look for main. 41, 42. When the function terminates, it always branches back to main regardless of where it's called from.
True.
True.
False. If you just remembered what we just did a minute ago, a function can call another function. When you call the validator class, it didn't go to main. It went back to where it was called from. Does that make sense? The return, when you finish a main function, it always goes back to where it was called from. In that validator class in the validator function that we wrote, it was called within another function. It didn't return to main. It returned to that function where it was called from, and that was not main. So in this question 42, when a function terminates, it always branches back to main regardless of where it's called from. No, it goes back to where it's called from. 43. Arguments are passed to functions in the order they appear in the function call.
True.
True. The scope of a parameter is limited to the function which uses it.
Is that also true?
That is true because remember, a parameter is just that placeholder. It's just that placeholder in that function. That's why I'm always saying, let's get the lingo understanding because that's where it's going to trip you up in the quiz and test. 45. The changes to a function's parameter always affect the original argument as well.
False.
False.
False. My bad.
It's false. Good. It depends on how you pass it. It doesn't always. 46. In a function's prototype, the name of the parameter may be left out.
False.
True. Remember, in the prototype, we just put int and so forth. We do not put the name of the variable, name of the actual parameters. We only put the data type. (47) Many functions may have local variables with the same name. True. True. 48. Overuse of global variables can lead to problems.
True.
Didn't you say we should never use those?
Bingo! Yes.
I think you
If-
said. Oh.
Go ahead.
No, I think didn't you say like the only time to use global variables if they're constant?
They should be constant if you need to have them. But in this course and in many other real life situations, they should never have global variables. You would pass the variables as needed. And if need be, you can look them up. Sometimes they have property files that gets passed around. But you do not have global variables throughout your application. No, 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 no. I tried doing that once when I first started learning programming and I was like, oh, I'm going to put it up here, and that way I don't have to worry about it. Nope, I got slapped real quick. So no. 49. Static local variables are not destroyed when a function returns. True. Remember, local variables in that case always persist those values. 51. Initialize of static variables only happens once regardless. Oh wait, 50. All static variables are initialized to -1 by default.
True.
False. It depends what the data type they are. If they're ints, they're 0, and I think if they're characters, are null or empty. 51. Initialization of static variables only happen once, regardless of how many times the function in which they are defined is called.
And true.
True. It only initializes once. 52. When a function with default arguments is called and an argument is left out, all arguments that come after it must be left out as well.
False.
No, that is true. Because all defaulted parameters must be listed first, and then after ones that you have concrete ones, we know you can actually pass that they cannot be interchanged. So that one would be whatever that was.
That was 52.
52, that's true. When a function with the, I'm sorry, 52 is true. When a function with default arguments is called and an argument is left out, all other arguments that come after it must be left out as well. That is true. That is true. 53, it is possible for a function to have parameters with default arguments and some without.
That one's false. It is possible.
That is true. It is, like you said, but be careful of the wording. It says it is not possible. You're saying it is possible, and I agree with you, but the question says it is not possible. So in this case, it is 50. Let me see, 53. Yeah, that's false. I'm sorry. I misread it. 53 is false. Sorry. Getting tired. 54. The exit function can be called from main.
False.
Why can't it?
Well, can you also use exit from other functions?
Exit is a function that can be used anywhere, and it terminates the program. So it can be used in any function. Main is a function, so why can't it be used in main? They're saying right here, the exit function can only be called from main. 54 is false. A stub is a dummy function that is called inside of the actual functions it represents.
Wait, did you say 54 was false or true?
False.
I believe 55 is false. Isn't that called a static?
A stub is a dummy function that is called inside of an actual function it represents. That is true. It's a stub. Static, the only thing that we used with the static one was a static variable that keeps its value. So 55 is true. Let's see if there's any other good questions. Here's a good one. Number one, why do local variables lose their values between calls to the function in which they are defined?
Is it because of the function scope?
The function scope, yes. The function only exists within those parentheses. So when the function gets called, it puts all that information on a stack, and when that stack finishes, when that function ends, everything is removed. So the variable is no longer existent. What is the difference between argument and a parameter?
I believe parameter is declared. Wait. Oh yeah, argument is declared in the function scope in parentheses, and the that's the argument, and the parameter is can be declared anywhere else.
Repeat that again. I just want to make sure I heard it correctly.
That argument they're initialized from parentheses of the function, while the parameters, I believe, are declared elsewhere.
No. What is an argument? It's the actual value that's being passed to the function. It's the actual argument. The parameter in this case, and the parameters are just placeholders, and they are defined inside the function definition. Like here's int value. This right here is a parameter. It's a placeholder. This num C type right here is a placeholder. It's only used right here, and it's defined in the function definition. What do you define parameter? So I just answered this question. Where do you define parameter variable? In the function definition. Let's see what others. How do you return a value from a function?
From putting it by putting it the first word before the actual name of the function.
Say that again. Are you saying like this int?
Oh wait, no, that's declaring the return value. Returning it by typing return and the data type.
Like right here, return this.
Yeah, and that should be the data type of what's on the function.
What about if I want to return more than one value?
Ooh, interesting one.
can't you use reference?
Bingo. That's it.
Use
You would pass.
reference. You have to pass it in and out.
Yes, you got it. You use reference variables. What's that? Give an example when passing up. We just answered this question right here. Give an example where passing to argue by reference would be useful. If you need to return more than one value, you pass it as a reference. Very good. Let's see on the slides, see if there's anything else that is important. Chapter 6. Functions. So I covered everything. Module. Know how to call functions. Know the function definitions. Prototypes. Remember your quizzes and exams will use prototypes, but you don't need them. When you write your own code, I'm not going to be stickler on whether you use a prototype or not. Just be consistent. Know how functions work. You call them and they call, and then when they return, they go back to where they are called from. Know the difference between arguments and parameters. Don't worry about this formal stuff. Know this function calls right here. Values argument is copied into your parameters when the function is called. That is called pass by value. When the values are copied, when there's no ampersand, that's what we call pass by value. Passing multiple values, that's what we just call passing data by value. It's a copy of the value, so changes to that parameter will not be changed that argument. The return statement, you know how it works, and so forth. Boolean values can be used. We just saw that right there when you validated. Local variables. The main thing between local variables and global variables, know that local variables are not initialized unless they're static, but global variables are initialized if you do not give them value. However, no one in this class will write global variables, but like it says, if you're going to have to use it in any situation, you should make them constant, which forces you to give them value. You give them local variable lifetime. A function's local variable exists only while that function is executing. It's no longer removed. Know this. And the global variables and global constants, know about that. And the static ones, how they handle, they only initialize once. Default arguments, be knowledgeable on them. In reference variables, remember if they have that beacon, be careful if you ever see this ampersand. Be very cautious on the placeholder of that argument because it could potentially be changed. And when you're using this by reference, this ampersand, it's no longer passed by you, it's passed by reference. Overloading functions, know that it's the same function prototype with the same return type, same name, but just different argument list. And how the exit function works, it exits the entire function. No matter where it's called, it exits the entire program. It can be called anywhere. Stub, when you guys writing when you go over Lab 4, it's good to start with using stubs when you start writing your functions to make sure you get there. And drivers. Any other questions so far?
So far so good.
All right. If everyone's good with chapter 6, let's look one more time at the syllabus to make sure everything's right. To do October 5th. Remember, we covered we did practice review on the practice programs. We reviewed Chapter 6. Wednesday, we will have your quiz. Please make sure you take it by 8 p.m. There will be no formal class. We're not going to go over anything new. But I will be here if you have any questions about the midterm. I will not give a review for the midterm. I've been giving reviews for each individual chapter. If you have questions for the midterm, bring them on that day. I think right now we covered 6 chapters, and I think last time I looked at the midterm, I took the program, I was nice to you guys. I didn't take off the programming question, but I gave more multiple choice questions, so that way they're worth less points. So in case you miss one, it doesn't hurt you as much. We covered about 6 chapters, so I took about 10 questions or so from each chapter. So it's about 70, 75 questions. You will have about 3 hours to take the exam. That is plenty of time to take it. It's similar questions to your quizzes, multiple choice, true, false. You have 1 attempt to take it. It's 3 hours. Normally when it was in class, I was same thing. There was no Scantron, just scribble your answers on the sheet of paper, and they also had a handwritten programming assignment. They didn't allow them to use the computer. So I took that off and just gave you more multiple choice questions. But if you have any other questions or concerns or need help practice for the midterm, bring them that day. Ask specific questions. I will not give a review or anything like that, but if you have questions against let's say a topic of passing parameters to a function, we can go over that. Or you have problems with the increment and decrement or while loops, we can go over that, but bring specific questions. I'll create a lecture for a session that if students need to ask questions, I will be there. But if no one shows up, I will sign off. Any questions, the way Wednesday is going to happen. Take your quiz, I'll create a session, and I'll stay on it. The class starts at 6:30. I'll say from 6:30 to 7. If no one signs on for questions, then I will sign off. But if you need help and you have questions regarding your lab, regarding questions for the midterms that you have stuck on a certain topic, here's your time to ask the questions or email them. Any questions so far?
Will you make a review, like I don't know, like a document with terminology or something like that for it?
I don't have that, but if you need like reviews, you have your quizzes, correct? You can look back at those. Those are good questions to ask.
Okay.
But if there's certain things, terminologies, wording that you would want, email me, bring them to that class, bring them to Wednesday's class and ask them, and I'll talk about it. After that, Monday is your midterm. There will be no class that day. Well, there will be class because you have to take your midterm. It has to be taken that day, but there's no class afterwards because you have those 3 hours to take it. And then following that, we'll start with Chapter 7.
What time on Monday do we have to take it?
Anytime. I will try to make it open like I do with the quizzes. I'll keep it open from, let's say, 8 a.m. to 8 p.m. So it would be available to take.
All right.
Because I don't know how your availability is, and since this is not a formal class, it's a pseudo-formal class. We do have live lectures, but I'm not forcing you to be in the testing facility or anything else because of COVID. I will try to set it up that it'll be available all day till, let's say, 8 p.m. at night. As long as you sign on, or I might say it later, as long as you sign on by 8 p.m. to sign it, you will not be cut off at, let's say, I started at 8, the instructor said I had 3 hours, and it's 9, and it's going to cut me off. as long as you sign in, you have those 3 hours. Any other questions or concerns?
So I had a question about the major project that you wanted us to do. Do you have like an example of, because you said it's like a creative project. I forgot which one it was.
Lab 6.
Lab 6. Do you have any
Yeah.
examples, any good examples of
Yes.
kind of interesting creative work?
What I did when I first started to do that class, I thought I have one in there for labs. For this, I use it as a template. When I first taught this class and I did the Lab 6, I made them write a vending machine simulation. And so what it was like a menu-driven thing, let's say Coke, Dr. Pepper, whatever you wanted. And I gave them rules. I could try to give you the mock-up of that, but they wrote a vending simulation. And so like press 1 for Coke, and they had to keep it with the structure and quantities and all this stuff. So that was their Lab 6. So you could do something on that level. I had also students create text-based games, creating characters, wizards and warlocks, and one of them also did a hangman game, and he spent most of his time see out the actual hangman. So if you mistype the character, it would clear the screen and draw the head. And you missed again, it drew the neck, and so forth. So students came up with a lot of good examples. So I'll throw some out there: text-based games, hangman. You don't necessarily have to do the Coke vending machines and so forth. Does that kind of help you out?
Yeah. And I have one more question about you talked about we're never going to ever use global variables, but let's say someone did use global variables, since they exist outside of the main function and outside of any function, do they have like special properties that could be abused, like let's say like inject it with my own code or something? If I'm, let's say, within the program, it lets me change a global variable, could I then maliciously use that to inject some kind of code and run something in the back because it's not within a function?
Well, things with the global things, a user would not have access to it. Usually when if you're talking about if you use global variables and you do not have a constant, I don't know if it could be used like that, because most of the time when you use global variables, you use a primitive data types like int, float, double, char. You don't use it as a string, because if it's a string, then you might be a little bit cautious on it, because in, let's say, web-based forms and so forth. Oh crap! Hold on, someone's calling. Okay, so I'm just gonna hang up on them. There always been some security risk at times when, let's say, a user's typing in a string in a web form. Well, they can put in a malicious script into that text file. And then what happens on the back end, that string could be parsed or could actually be run, so it can cause potential problems. That's why a lot of things that you don't use global variables, but there's also a lot of security things that should not happen, because they put concepts in place. Let's say for that text-based string, when you read it, it's not global, but it's local, and that can still call malicious intent. But for your question regarding global variables, no, because normally ones they shouldn't have it, and most of the time, since they're global and they're constant, and they're usually primitive data types such as ints, doubles, and floats, so there's nothing able to really run, if that answers your question.
Wait, can you say that again?
Because most of the time when you use global variables, if you use them, in this case you don't, most of the time those global variables are either constant, and if they're not, they're primitive data types, int, double, float. So there's no way that you can run some kind of, your question was any kind of malicious thing on the back end, correct? If things get changed, correct?
Mm-hmm.
You're changing a numeric value or character, a primitive data type, right?
Mm-hmm.
So what can you run or do maliciously if you're using a primitive data type such as an int, double, float, and so forth?
Okay. No, I was asking because I was interested in making like a, because do you know what CTFs are?
But what are CTFs?
Oh, capture the flag, like kind of thing. I was thinking I'm trying to make a program that is like, oh, you're a coder, you understand how to, and you try to force the program to do a specific thing, and it's like a challenge kind of. I don't know.
Okay.
If that would fit within Lab 6.
Remember what Lab 6 is, you can write it up and we can talk about it, but I have to agree to it.
Okay.
But all it has to do is decide, let me see if I change, last time I changed this because 20 points for 6. Yes, it has to have all this criteria. It must be reading from a file or writing to file. Looping, it must use the structures that we will talk about later on in Chapter 11, have data validation, and use functions. These are the only requirements that I put upon you. Whatever you want to implement is up to you. And this is my grading rubric of how I'm going to grade you.
But because you said we should never use global variables, I'm saying if you purposely put in global variables as like to try and, I don't know.
See if you can find it. If you're going to try to capture a flag, see if you can try to use it without using global variables.
Okay.
Any other questions? Let me stop the video. That's good. But that's good. I'm glad you're thinking ahead.